lecture 24. Let us continue with what we have been discussing, that in a differential equation. In my last lecture I told you the solution due to forcing function can be found very easily, provided the right hand side you can express it in terms of e to the power s t. If s equal to 0, it means it is equal to p constant, and I told you this equation can be written as, sometimes I am writing a d like this. I hope you understand this point, is equal to p into e to the power s t, where d is the operator, d dt, that is fine. Now, what it is being told is that solution due to forcing function will be p into e to the power s t divided by d square plus a d plus b, but this is to be evaluated at d equal to s, whatever s is there. That means, it will be equal to that input signal divided by s square plus a s plus b, is not, everything is known. So, solution due to forcing function can be found out very easily, and of course, other two terms will be there, exponentially decaying terms as natural response. Now, is there any restriction on s? As such, no. S could be any number, real number, also it could be a complex number, no problem. Okay. So, for only thing is, see, you are evaluating this denominator by putting d equal to s. It may so happen that this will give rise to 0, then you are will be in trouble. Then you have to see, you have to integrate, or the way I told, you have to solve the problem. Got the point? So, except at the conditions when the denominator does not vanish when you put d equal to s, that is there. But in most of the cases it will not be, and it is a very handy tool to find out the solution. Now, I started telling you that if the right hand side is a sinusoidal excitation or a constant value, then the forcing function, solution due to forcing function can be easily calculated using this. Now, the question is, suppose I say I have solved this problem, I will recall that problem and try to apply that. For example, an RL circuit is there and you excite this with a sinusoidal voltage V m sin omega t. There is no exponential as such, and at t equal to 0 you close this switch. This is RL. This we have done classically, finding out the constants k 1, k 2, etc., and including the constant a. So, it is a first order differential equation. What was the equation? It was L d I dt. Let us do this here, plus R I is equal to V max sin omega t. That is what I wrote it here, is not? That was the thing. Now, and then I was dividing, which is not necessary, but you always follow this, R by L into I is equal to V m by L sin omega t. Now, what will be the solution of this is known. I wrote it earlier as I t, total solution will be a into e to the power minus R by L into t plus some constant k 1 sin omega t plus k 2 cos omega t, etc. I did this earlier in this way. Now, let us do it in a different way, so that I can utilize this property. Okay. So, on the right hand side as such there is no exponential term, but if you look carefully you should know from complex algebra that sin omega t can be written as e to the power j omega t minus e to the power minus j omega t divided by 2 j, is not, because this is true, I think, cos omega t plus j sin omega t, this is the first term, minus cos omega t minus j sin omega t. If you put this is by 2 j. So, on the top it will be, this term will cancel, 2 j will cancel, give you. So, this is the important thing. Similarly, cos omega t can be written as, whenever necessary you will use also that, e to the power j omega t plus e to the power minus j omega t divided by 2. So, these two relations are very interesting. Therefore, I will get in this problem that this was the differential equation d I dt plus r by L into I is equal to V max sin omega t, but this I will now write it as V m by 2 j into e to the power j omega t minus e to the power minus j omega t. This way I can write. Therefore, on the right hand side you have got V m by 2 j e to the power j omega t and minus V m by 2 j e to the power minus j omega t. So, it is here the value of s is for this one, s is j omega, and for this signal it is s is minus j omega. Therefore, as if you have excited the system with two input signals, and since I have told you R and L circuit with initial condition 0 behaves like a linear circuit, therefore, I can apply superposition theorem. For e to the power this signal I will find out what is the response, for this signal I will find out what is the response, and I will add them up when both of them will be present. That is how we did it. So, that is how the things will be. So, the solution due to this function, if I want to write it in one stroke, I will write it like this, follow me. I t total solution will be equal to e to the power minus r by L. This thing, okay, that is the most simplified way. Find out the root, e to the power minus r by L. Then we are doing the forcing function. Now, this is the differential equation d I dt plus r by L into I is equal to this. This is one input signal, subtracted another input signal, and I will apply superposition. So, first take this term. What I told, the solution due to, so this equation is d plus r by L into I, or equal to this, is not d plus r by L into, no, yes, correct, this is the thing. Then solution due to forcing function will be the input signal, I write it V m by 2 j into e to the power j omega t divided by d plus r by L. You bring this down here on this side and evaluate it at d is equal to j omega. What is the value of S? J omega for this signal. Then minus once again another exponential signal whose S value is minus j omega. So, e to the power minus j omega t, that is fine, divided by d plus r by L into d is equal to minus j omega now. Got the point? So, I have applied superposition to these two signals. It was only real signal sin omega t. I converted to as a difference of two exponential signals. So far as this difference, see everything is real here. So, do not worry about that, but this real signal V m sin omega t can be thought of two exponential complex signals, difference of that. But there was no restriction on S, it could be imaginary as well. So, this is the thing you got. So, I will write the total solution I t as A into e to the power minus r by L into t plus of V m by 2 j is there, and on the top it is e to the power j omega t, and below it will be r by L plus j omega, is not. For d you have to substitute j omega minus V m by 2 j into e to the power minus j omega t divided by, here for d you have to substitute minus j omega. So, it will be r by L minus j omega, is not. So, this will then become equal to, you have to do some algebraic manipulations, complex algebraic manipulations, plus V m by 2 j, let it be there because it is common here. Now, below it will be e to the power j omega t, this one. So, a plus j omega, V m by j omega I have taken outside for both. So, here it will be r by L plus j omega into r by L minus j omega, is not, denominator. I am just subtracting them, and then it will be here r by L minus j omega and minus e to the power minus j omega t and r by L plus j omega. Is it correct? That way it will be. So, the solution then will be, I will copy this thing. I start from there. So, it was some terms from the top came. This was minus j omega t, is not, and there was bracket, is it? This is okay, hopefully. So, this is the thing. So, I just simplify this. So, this is equal to I t, total solution a into e to the power minus r by L into t plus V m by 2 j, and then below it will be r by L whole square plus omega square. A plus j b into a minus j b is a square minus b square. If you do, this will become plus, correct. Then on the top what you will be getting is this r by L, if you take common, it will give you e to the power j omega t, and from this r by L it will give you minus e to the power minus j omega t. These two terms I have taken, and then you see minus j omega, if you take common, it will be e to the power j omega t from this, and it is also minus. So, this will become plus e to the power minus j omega t. Is that correct? So, this will be the thing. Now, this you have to only simplify this minus r by L into t plus V m by 2 j. So, this will be equal to r by L whole square plus omega square. Now, this one, as we have right now told you, this is equal to r by L into 2 j sin omega t. Right now I have told you, and this will be equal to minus 2 cos omega t. So, minus omega 2 j cos omega t. Always remember that e to the power j omega t plus e to the power minus j omega t is equal to 2 cos omega t, and e to the power j omega t. We will be using this very often in circuit analysis, 2 j sin omega t. That is what I have done here. Clear? Now, this 2 j business goes, and your solution is a into e to the power minus r by L t plus V m by here this can be written as r square plus this denominator, this L square, and on the top there will be an L square coming in, and it will be equal to sin omega t, is it, minus omega cos omega t. Is that correct or something I missed? Hopefully, it is correct. One thing I missed here. See, I divided by L, got the point, is not? This was the differential equation. I started, you should be careful. See, di dt r I by L. So, here was that L term was in the V m by L. So, everywhere it was L. Got the point? So, you should be careful. Let me put in different color. This L I missed, because in the excitation it is there, coefficient V m by L. Not L, this is also L, this is also L here, clear. Hopefully, I have incorporated everywhere L. So, this one was L was there, so this was L. Now, this was also L. Now, here was 1 by L square and there was a L here. This L square I pushed it up. So, you have only one L left here. So, your solution will be a into e to the power minus r by L into t plus V m by r square plus omega square L square. This L you push it inside, it will be r sin omega t minus omega L cos omega t. And this one I have done just 2 lectures back, that this you now you can write this as this thing, but let me do that so that you do not miss any point I want to make. So, So, this is your IT total, I got this, all the things are there. See, first thing you should note is this, that there was a circuit RL which was excited by a sinusoidal voltage. And everything was real. Therefore, response in the circuit ultimately, although in between some complex number came e to the power j omega t, but ultimately I expect it should also have real number. So, things are correct. Why a response will be complex? It will not be. These terms conspire in such a fashion, the imaginary terms vanish and everything is real. You have applied real signal, you are getting real signal. For getting some advantage in computation, I converted that real signal sin omega t as sum of e to the power j omega t minus e to the power minus j omega t by 2 j omega, that is there by 2 j. So, it is like this. Then rest of the things I know how to handle. So, everything is real. So, this is V m by this I will only write r square plus omega square L square, and this will be as usual root over r square plus omega square L square minus omega L by root over r square plus omega square L square. Here is sin omega t and here is cos omega t. Then you define this term r by this as some cos theta, then this has to be sin theta, and then you get the same answer as I have got earlier by using k1, k2 etc. So, V m by this, if you call it as Z impedance, you must be knowing, into this will be then written as sin omega t minus theta, where tan theta is equal to omega L by r. You got the point. You therefore, I think the number of computations things have become less. In fact, with numbers, if the circuit is given, it will be much faster, because I am carrying on all the variables r, omega, L. If some numbers is given, you can do it rather fast. Okay? That we will see. The second thing I want to tell you about another problem which I have already solved. For example, an RL circuit. RL circuit is there and you have a DC source. See, I am trying to do same problem in different ways, then choose your method. So, this was E, and I want to find out current, but this time I am applying a DC voltage. So, what will be the thing? This drop is L di dt. So, L di dt plus R I. Do not write down this differential equation without showing the direction of the current and the polarity of the voltage. Always draw the circuit, direction of the current indicate very clearly, then polarity of the voltage correctly, and from this I will get this, but this time this is what? Constant. But constant can be written as E into e to the power 0 into t, this is 1. Therefore, I will say this time the total solution I t will be equal to better the way I am always doing. So, this is fine, then d I dt plus R by L into I is equal to E by L. this is exactly that L I missed in my earlier thing. So, E by L, not 2, and this is equal to E by L, this constant number E L are constant, e to the power 0 into t. So, this is the differential equation in the form you try to express. Then you say I t will be equal to a into e to the power minus r by L into t, characteristic root, plus E by L input, which is equal to E by L, e to the power 0, divided by d plus r by L, d plus r by L, and for this value d you put 0. That is what. So, this equation is nothing but d plus r by L into I is equal to E by L. So, this can be expressed in terms of e to the power s t, where s is equal to 0. I am so sorry. D equal to s is 0 here, s is 0 in this particular problem. So, d equal to 0 you put. So, if you do that, you will be getting a into e to the power minus r by L into t plus E by L and r by L, this L goes, that is all. So, solution due to forcing function can be very easily found out, and then rest of these steps you know. This is your IT, then apply boundary conditions to get A determined. So, what is the thing that if an excitation is given, and if that excitation can be expressed exponentially as sum of two more signals, then the solution due to forcing function, where those k 1, k 2, k 3 were involved, in that sense your labor is reduced to a great extent. Fortunately, in network analysis, one of the very important signals are sinusoidal signals or constant value signals, either a battery or sinusoidal voltage source. So, it is worth studying then if your input signal happens to be either constant or a sinusoidally varying source. You cannot apply this, mind you, for any arbitrary voltage source or current source. You can you cannot do that. But then an important signal in network analysis, in signals and networks, is sinusoidal signals. Therefore, it is worth studying why it is like that. Later we will tell you something more about this. These are called characteristic function of this system and so on. That we will take later up. But now, as you see, I did not really solve this RC problem. I told you to solve, but let us also solve it in this way. I will give you indication to this. Suppose a sinusoidal voltage you have applied. This problem I told you worked few steps using those constants k 1, k 2, etc. But let us, in the light of this one, let us try to approach that problem, sin omega t. So, first of all I will write V t is equal to, you are applying a sinusoidal voltage sin omega t. I think V s t, this is the supply voltage, V s t, and this then I will write it as V m by 2 j and e to the power j omega t minus e to the power minus j omega t. This is my input voltage. And what is the current in the circuit in terms of the capacitor voltage? This is V t. So, the current in this circuit I t is equal to C dV dt. Therefore, KVL equation plus minus R I, that is R dV dt and plus V. So, R C dV dt plus V t is equal to your V s t supply voltage, which happens to be equal to V m by 2 j, two sources, minus V m by 2 j e to the power minus j omega t, and initial condition given is V 0 minus equal to 0. So, that I can apply superposition theorem and so on. So, this is the thing. Therefore, the first step is dV dt plus 1 over R c into V is equal to you divide by this thing 2 j R c e to the power j omega t minus V m 2 j by R c. I divide both sides by R c, and this is the thing e to the power j omega t. Is it? Then what will be the solution? Voltage across the capacitor at any time t will be the characteristic root, that is the natural response, will be e to the power minus 1 by R c into t. That part you have to do. What is the characteristic equation? D m plus 1 by R c equal to 0, that is all. From this you find out minus 1 by R c, that part is over. Then the next part, the voltage across the plate of the capacitor, and here is an exponential input. So, I say that V f t, I write it separately, that is the solution due to forcing function. V f t will be, here is an exponential. So, that voltage V m by 2 j R c into e to the power j omega t, that is the input, divided by d plus 1 over R c, because so d plus 1 over R c, but you calculate this for d is equal to j omega. Then minus V m, this is the input signal e to the power minus j omega t, divided by d plus 1 over R c into this to be evaluated at d equal to, what is the value of s? Minus j omega, minus j omega. And let us proceed. So, solution due to this term V f t will be equal to, put that number V m by 2 j R c into e to the power j omega t, and if you put this number here, it will be 1 over R c plus j omega, this term, first term, and then minus V m by 2 j R c, it is there. Then you have to put d equal to minus j omega, e to the power minus j omega t, and this divided by 1 over R c minus j omega. You have to just manipulate this. So, what it will become? V m by 2 j R c come outside this factor, take it outside, and then below this into this, a plus j b into a minus j b is a square plus b square. So, here a is this one, 1 by r square c square plus omega square, no imaginary thing vanishes in the denominator. Then you are adding these two terms. So, it will go up 1 over R c minus j omega into e to the power j omega t, this into this, minus 1 over R c plus j omega into e to the power minus j omega t. That is the thing you will get. Once again, this can be written as, let us complete this, so that at least to some extent let me complete. So, this is the thing you copy. go to next page and paste it. So this is the thing we have got. So this is equal to only the solution due to forcing function. It will be like this. I think this came from previous thing, na? And here was the bracket close. This was the thing. Anything missed? No. So this thing is V m by 2 j R c, that is fine, and below it is 1 over r square c square plus omega square, that is also good. Then you see it is 1 by R c, and you will be left with e to the power j omega t, and 1 by R c minus e to the power minus j omega t, it will be there. Then minus j omega, this term and this term, and both are minus. So, it will be inside the bracket, it will be e to the power j omega t plus e to the power minus j omega t. Clear? So, this is the thing. Then rest of the things are just manipulation. With complex numbers you should be very careful. So, this is equal to 1 over r square c square plus omega square, below it is there, do not touch that, and here it is 1 over r c, and this thing I have learned, it is equal to 2 j sin omega t, and this thing I learned, it is cos omega t. So, minus 2 j omega cos omega t, that is the thing. Now, this 2 j goes, everything should ultimately becomes real, because we are dealing with real circuit, everything is real. So, it will be like that. Got the point. So, this will be the thing. Now, what you do is this, hopefully everything is fine. You can multiply with r square in the numerator and denominator. So, if you multiply with r square, so or what should I do, omega square c square, let me write. So, this can be written as 1 over r c omega c, ठीक है. So, you write it like this, below 1 you divide first by omega square c square, r square c square on the top and bottom. If I multiply and divide by r square c square, you multiply this one. So, this then will become, below it will become 1 plus omega square r square c square, it will become, and on the top 1 r c goes here, 1 r c will go, and this r c will make it 2 sin omega t, two j gone. So, r square c square I have multiplied, it is like this. So, 1 r c was here, I cut it, this r c I am entering here. So, then it will be only 2 left, r c goes, this r c goes, and 2 sin omega t, 2 will not be there, right, and then minus r c omega cos omega t, it will be like this, clear, and outside it is V m. This will be the thing. Now, we will write down another way, because your see impedance we know r square plus 1 over omega square c square. So, in that fashion I want to bring it, and I will be able to manipulate. How? Huh? So, I divide divide numerator and denominator, divide by omega square c square. I think you can do better than what I am doing, but essentially, so I am dividing by omega square c square in the numerator and denominator, and so what I will get it here is r square plus 1 over omega square c square. I will get it, and on the top what I will get, omega square c square. If you divide, it will be V m 1 by omega c, 1 omega c you keep it outside and another one you enter, minus r cosine omega t. Yeah, that is the thing. You do in your own way, but the point I want to make, it will be like this. Then in the same way you say that this is the voltage across the plate of the capacitor due to forcing function, only forcing function. So, that will be eventually the steady state voltage. So, this can be then written as next time, that I will not proceed further, but I now know what is happening. V by omega c is there. So, you take out r square plus 1 over omega square, the same way I did for this one, and this one can be written as 1 over omega c root over r square plus 1 over omega square c square sin omega t, and minus r by root over r square plus 1 over omega square c square. Hopefully, I have done correctly. You check it nonetheless. Then you define this to be sin theta and this to be cos theta. Then sin A, sin B minus cos B, cos B. Clear? So, if you do like that, then VFT can be simply written as Vm divided by 1 over omega c, sorry 1 over omega c divided by r square plus 1 over, okay, dimensionally also it is coming correctly, into you define this term to be sin theta. And this term to be cos theta, you know. If it is cos theta, it has to be sin theta. If that is the case, so sin A sin B minus cos A cos B is what? Minus cos A plus B. So, it will be some minus cos A plus B theta, where tan theta is 1 over omega c divided by r is equal to 1 over omega c r, that is reactance by resistance, etc. So, this will be this voltage. What has happened? So, this will be the voltage, everything is defined, where tan theta is this one. If you like, you then calculate the currents, C dV dt will be the current. Do not get upset by this negative sign, because it is not that this is the voltage. You see Vm by Z is the current into reactance gives you the peak value of the voltage, that is fine. But in a capacitive circuit, this is your supply voltage, we know that this is correct, supply voltage is Vs. I mean, although I have not done phasor diagram, but I am trying to see whether things have gone getting correctly. So, current will be leading here, current will be leading, and capacitor voltage will be voltage across the capacitor will be lagging this, is not, this is the supply voltage, current drawn in the circuit leads it by theta, that is fine, but voltage across the capacitor will be lagging the current by 90 degree. So, these things constitute to this negative sign. Anyway, do this, but the emphasis I want to put on these particular lectures and the last two lectures is that in case the excitation function happens to be DC or sinusoidal, sinusoidal things can be expressed in terms of your sum of two complex exponentials, then you are through very quickly, you can calculate. And as I told you, if these are numbers, here I was struggling a bit here, but anyway you can handle these situations. This is hopefully correct, you check that and inform me through mails or whatever it is, if anything has gone wrong. Most probably everything is fine, then you get. Although the phasor notation I have not yet introduced, but for my own benefit I wanted to check whether I got the correct results, hopefully it is correct. So, I will continue with these things in the next class. Thank you.